Okay, today we are looking at the second part of time value of money. So we'll be focusing on the power of compounding, on even cash flow, frequency of compounding, effective annual rates, and amortization. Okay, so I give you 1 minute to read this question. So you can see that from this question, a 20-year-old student is trying to target 1095. But before she can do this, she needs to have a strategy of saving $3 every day. So $3 every day multiplied by 365 days in a year, she will be able to get 1095. And then she decided to invest this $1095 in a brokerage account with an expected annual return of 12%. Now, take note of this age because he or she is just 20 years old. She will reap the dividend of starting to invest early. So investment can give you higher return in the future if you start to invest now. So how much money will she have when she is 65 years? So let's see how much she can earn when she becomes 65. Now, between 20 and 65 means that she invested for 45 years. 65 minus 20 will give you 45. So that means her investment is for 45 years because she started at the age of 20. So let's see the calculation. So you can see you're already familiar with how to use the calculator. So I will not spend much time because you can always key in and get the value. So if she starts to invest at the age of 20, our N would be 45. How do we get 45? 65 minus 20. 65 minus 20. So we get 45. So that's how we get the N. So you key in all this value, you arrive at the future value, which is 1,487,262. So you can see that if you start to invest early now, when you are young, you can actually become a millionaire after 40 years, or the longer the years, the more richer you are. So this is one of the benefits of learning time value of money. It helps you to know that you need to start to invest very early. The rich they know this principle. That is why when they give birth to their children, they start to invest for them. So that by the time the children grows up, they are already a millionaire because their father was wise enough to start to invest. Immediately they come to the world. So let's see what happened. What if there was a delay? If you don't start to save, but you wait until you are 40 years old, how much will you have at 65? So if you start late at 40, it means you only have 25 years to invest. So 65 minus 40. So that is why we have N is 25. So the interest per year is 12%, already given in the question. The PMT is 1095. We already calculated 1095 for the PMT. So you can see that if you delay till the age of 40, you only have less amount. You can see you only have 146,001. But if you start early at the age of 20, you can become millionaire. 1,487,262. It's a big difference. You can see this is because of the power of compounding. The power of compounding. So your interest will earn more interest. So the earlier you start to invest the money, the faster it is for you to become a millionaire. Okay, because there is a delay till 40. What can this 40-year-old do today in order to catch up with this target of achieving 1,487,262? Let's see what you can do. You notice that for the 20-year-old, the PMT, that is the annuity every year, is very low, 1095. Why? Because she started early. So let's see what happened. You can see if there is a delay before starting to invest, the PMT will increase. You can see the PMT has increased to 11,154. So the PMT is the annuity every year. It has increased to 11,000. So in order to catch up with the 1,487,262, you have to pay the price. And the price is paying higher annuity. So the summary or the lesson you can learn from here is that it is better to start to invest early. This is uneven cash flow. So uneven cash flow means that the cash flow every year is not the same. You can see that the cash flow in year 1 is 100, in year 2 is 300, in year 3 is 300, in year 4 is minus. So this type of cash flow pattern, you cannot use the annuity method. It has to be done in a manual way, manually. Or alternatively, there's another way you can solve this. I will show you later. It is inside the manual I gave to you. So when we get to the capital budgeting, we are going to be using more of this type of cash flow. Then you will understand how to use your financial calculator to calculate the NPV when you have uneven cash flow. So for now, we don't want to disturb ourselves with this. So later on, you will understand it better. But just to give you an idea of how it is done, for you to calculate, to get this value, you can use your financial calculator. With the financial calculator, you have to follow some steps, whereby you key in the cash flow for year 0, cash flow for year 1, cash flow for year 2, cash flow for year 3, cash flow for year 4. You enter your interest per year, which is 10%. You press NPV button, then you can get this value. But if you follow this process now, you will not get it because this is just a summary. It has a more elaborate steps, which will be shown to you later from the manual I gave to you last time. So what will the future value of a lump sum? Will the future value of a lump sum be larger or smaller if compounded more often, holding the stated 1% constant? So what this slide is trying to tell you is that there is a difference between if the compounding period is annually and if the compounding period is semi-annual. Semi-annual means that you receive interest 2 times in a year. So annually means you receive interest 1 time a year. So of course, when you receive interest 2 times a year, you will have a higher value. You can see the value is higher, 134, because the interest is done twice a year. Now, if you look at this example, if the interest is done annually, you only have 3 years. You earn interest in year 1, interest in year 2, interest in year 3, 3 times. But if the interest is semi-annual, you earn interest 2 times in a year. So you have 1, 2, 3, 4, 5, 6. So you earn interest 6 times. But in the case of the first one, you earn interest 3 times. That is why you can see the power is 3 here, the power is 6 here. So the more the frequency of the compounding, the higher will be the future value. So there are different types of interest rates. So, and it is good to understand them so that you will know the right one to use when you are using your financial calculator. The first type of interest rate is called nominal rate. So nominal rate is also called the quoted or stated rate. An annual rate that ignores compounding effect. So this type of rate it doesn't take into consideration the compounding period. It is usually stated in a contract as it is. Period must also be given. For example, it can be 8% quarterly or 8% daily. So it is usually stated as it is. Another type of interest rate is called periodic rate. So periodic rate is the amount of interest charged each period, e.g. monthly or quarterly. So you can see the difference. In the case of the nominal rate, it is quoted and stated the way it is. For the periodic rate, it is charged each period. It can be monthly, it can be quarterly. Now, the periodic rate will be equals to the nominal rate divided by the M. So M is the number of compounding periods per year. For example, if M equals to 4, it means for quarterly period. If M equals to 12, it means for monthly compounding. So this M can take a value of 1 up to 12. Another type of interest rate is called effective or equivalent annual rate. This one is very important. Effective annual rate. The annual rate of interest actually being earned considering compounding. So this type of interest rate, it takes into consideration the frequency of compounding. And this one is very important when you are calculating in time value of money. It is very important, especially when you are using your financial calculator. For example, the effective annual rate for 10% semi-annual interest. So semi-annual interest means that interest is earned 2 times in a year. So we need to use this formula. Effective annual rate equals to 1 plus the nominal rate divided by M, which is the frequency of compounding, raised to power M minus 1. So 1 plus 10%, it's already given, divided by M. M is 2. Why? Because semi-annual, raised to power 2 minus 1. So you do this calculation, you divide first, you plus to 1, you raise to 2, you minus 1, you get 10.25%. So what it means is that you should have, or you should be indifferent between receiving 10.25% annual interest and receiving 10% interest compounded semi-annually. So this effective annual rate, it takes into consideration compounding period. You can see before we can arrive at 10.25, we did some adjustment. We did some adjustment using this formula. That is why it is called effective annual rate. It is commonly used in your calculation, in time value of money calculation. We normally use this one. So why is it important to consider the effective rate of return? It is important because investment with different compounding intervals will provide you with different effective returns. So if you have 2 types of investment, maybe one is semi-annual, another one is quarterly, you have to find the effective annual rate because the compounding period for the 2 investments are different. Effective annual rate is also used to compare investment with different compounding intervals. You must look at their effective return. Very important, otherwise you make the wrong decision. For example, you can see when the effective annual rate is annual, you can see that the rate of return is 10%. When the effective annual rate is semi-annual, you can see that the return is the effective annual rate is 10.25%. When the effective annual rate is quarterly, you can see that it's 10.38. So as the frequency of compounding increases, you can see that the rate also increases. So if you have 2 investments, one is annual, one is monthly, you cannot use annual. You have to use annual for the one that has annual, and you use monthly for the one that is monthly, so that you can get the right answer and compare the result. The reason why the semi-annual is higher than the annual is because interest is earned 2 times. The reason why the quarterly is higher than the semi-annual is because interest is earned 4 times. The reason why the effective annual rate for the monthly is higher than the effective annual rate for the quarterly is because interest is earned 12 times. So that is why it is higher. So when do we use, since we have 3 types of interest rate, when do we use each one of them? First, for the nominal rate, it is written into contract. It is quoted by banks and brokers. It is not used in calculations or shown on timeline. So we don't normally use this one in our time value of money timeline and calculations. The second one, periodic rate. It is used in calculations and shown on the timeline. So we usually show this periodic interest rate in our timeline. There's one rule. If M, which is the frequency of compounding, is equals to 1, then the nominal rate will be equals to the periodic rate. It only happens when M equals to 1. If M is different from 1, then the periodic rate and the nominal rate will not be the same. Only the same if one condition holds, M equals to 1. Effective annual rate used to compare returns on investment with different payments per year. It is used in calculation when an annuity payment don't match compounding period. So you can see that periodic rate are used in calculation. Effective annual rate are also used in calculation, especially if the compounding period is different. So let's look at example. What is the future value of $1,000 after 3 years under 10% if compounding is semi-annual, if compounding is quarterly? So let's start with the semi-annual. You still remember this, okay, this formula, future value of a lump sum payment equals to the PV multiplied by 1 plus the nominal rate divided by the frequency of compounding multiplied by frequency of compounding times number of years. So we apply this formula. 100 is given. 1 plus the nominal rate is 10% divided by 2. Why? Because of semi-annual compounding raised to the power of 2 frequency of compounding times 3, which is our n. So you can see that for the semi-annual compounding, the future value is 134.01. But for the quarterly compounding, you can see that the value is slightly higher, 134.49. So different compounding periods will give you different answer. And that is the reason why we need this effective annual rate. If we need to compare, we want to compare semi-annual compounding, quarterly compounding, we need to use this effective annual rate so that we can get the right comparison. So we can compare these two now. We can know which one is higher. From here, we know that the quarterly is higher. Can the effective rate ever be equal to the nominal rate? It only happens in under one condition. The effective annual rate will be equal to the nominal rate if M equals to 1. Only if M equals to 1. If M, which is the frequency of compounding, greater than 1, then the effective annual rate will always be greater than the nominal rate. Okay, let's look at this question. What is the future value of a 3-year $100 annuity if the quoted interest rate is 10% compounded semi-annually? So in this example now, compounding is done 2 times in a year. So the payment occurs annually, but compounding occurs every 6 months. That is 2 times in a year. 6 months plus 6 months equals to 12 months, 1 year. So we can draw the timeline, 1, 2, 3, 4, 5, 6. But we know that for the 3-year, 2 can be the first year, 4 can be the second year, 6 can be the third year. But in between 2, 4, and 6, we have 2 compounding period, 1, 2, 3, 4, 5, 6. So that is why they put it here, 100, 100, 100. Compounding is 2 times 1, 2, 1, 2, 1, 2. So this is how to draw the timeline for semi-annual compounding. If it is annual compounding, then it will be 1, 2, 3. So how do we solve this problem? How do we solve this problem? Because you can see the way it is drawn is different from when you have just 3 years, 1 year, second year, third year. So it calls for a different approach. So one of the approach you can use is to use this approach. Now, this approach is a bit confusing. So you will see the next approach, which is much easier. We have 6 timelines, but we know that if we go by normal annually, it's going to fall within this region, 1, 2, 3. So to find the future value, after the third year, for example, we have 100 multiplied by 1.05. Why 1.05? Because the compounding period in the question is 10%. So if interest is given twice in a year, we divide the 10% by 2, because semi-annual, 2 times, divide by 2, 5%. And that is why the 5% is here. So the 5% is here. Then you can see when you are here, you can earn interest how many times? 4 times. 1, 2, 3, 4. That is why you have 4 here. 100 multiplied by 1.05 is power 4. But when you are here, you can only earn interest 2 times. 1, 2. See, 100 multiplied by 1.05 is power 2. When you are here, you don't earn interest because you're already in the terminal point. So you have 100. So you total all of this together, you arrive at 331.80. Or you can do it faster using your calculator. Take note of the final answer here. Take notes. So let me go to the next slide. Can you see the same? The same. So this one is easy. Method 2 is better. 331.80. Can you see? 331.80. But this one can confuse you. So better to use this method. So how do you use this method? Firstly, you find the effective annual rate and treat as annuity. So to find the effective annual rate, you still remember the formula? The formula here. We use this formula here, something around here. So the formula appear again here. So 1 plus high nominal rate divided by m is the power of m minus 1. So what is our m? Our m is 10%. Sorry, our I is 10%. Our frequency of compounding is 2, semi-annual. M is also 2. Then you minus 1. So you get your 10.25. So you have calculated the effective annual rate. So the effective annual rate is what you are going to use as your periodic rate. Then you will get the same answer as if you are going through this long process. So instead of going through this long process, the first thing you need to do is to find the effective annual rate using this formula. So once you get your effective annual rate, you use it in your financial calculator, then you will get your final answer. So whenever you are given a question and the frequency of compounding is indicated, the frequency of compounding is indicated, it is better to calculate the effective annual rate first before you now use your financial calculator. We can also find the present value of this problem. To find the present value, similarly, our period effective annual rate is 10.25. Our future value now is 0 because we are looking for the PV. Our N is 3. Then we can find our PV as minus 247.59. Of course, you disregard the minus. You focus on the absolute value. of the PVT. So you already know how to do this, so I don't want to waste my time on this section. We already covered it last week. This one is very important. Loan amortization. So loan amortization are widely used for home mortgages, auto loans, business loans, and retirement plans. For example, when you want to buy a car, in most parts of the world, you don't pay cash at once. You get the car, you pay, let's say you get a loan and you pay installment. You buy the car and you pay installment. Or you buy a house, you pay instrumentally. Or you take a loan, you pay back the loan every month. So when you are paying back every month, we call it loan amortization, because as you are paying the loan, you are reducing the amount you are owing. So amortization table is related to present value problem. So financial calculators and spreadsheet are great for setting up amortization table. For example, construct an amortization schedule for a $1,000, 10% annual rate loan with 3 equal payments. Now, from this question, we can construct amortization schedule. You will see how it is done. But we need to go through some steps. From this question now, we need to find our PMT, because we are told that the amortization schedule has $1,000 and the interest rate annually is 10%. And there is equal payment, which is 3 equal payments. So what is this 3 equal payments? We don't know. So we are not given the annuity. So we need to find the annuity, which is the PMT. So the first thing we need to do, we need to find the PMT. So how do we find the PMT? We already know from the question, our N equals to 3. We know that our future value equals to $1,000. I know that our interest rate is 10%. All right, so you key in all the value. So you have your PMT. PMT here is 402.111. You can see, so this is your PMT, the equal payment. You can see that in the question, you are not told to find the PMT, but it is implied. It is implied in the amortization question that you have to find the PMT. They will not tell you. Sometimes they will tell you, but if they tell you, then it's too easy. They will just tell you, prepare a table. But for you to prepare the table, you need to go through steps. And step 1 is to find the PMT. So I'm sure by now, you know how to use your calculator to find this value of PMT. So why do they use PV? Because whenever you are repaying back loan, it is actually a present value problem. You can see that in the question, they didn't tell you whether it is PV or it is future value of annuity or present value of annuity. But write it somewhere. Anytime you are given amortization schedule question, even if you are not told that it is a present value problem, always remember it is a present value problem. Then the step 2. The step 2, you need to find the interest paid in year 1. How do you find the interest paid in year 1? You multiply the beginning balance by the interest rate. So what's the beginning balance? The beginning balance is 1,000. Can you see it? What's the interest rate? 10%. So you multiply the beginning balance by the interest rate. So 1,000 times 10%, 0.10, you get 100. So this is the interest that is paid in year 1. Year 1 only. Step 3, very important, you find the principal repaid in year 1. The principal repaid in year 1. Now, let's go back here. This PMT 402.11 already include interest. Already include interest of 10%. So inside this PMT of 402.11, there is interest charges inside. So how do we know these interest charges? So to find the principal repaid in the year one, sorry, we already find the interest, which is 100. Then to find the principal repaid, it will now be PMT, which is 402.11 minus 100. So 302.11 is actually the principal that you repaid in year one, because 100 is already interest payment. You can see this is the interest. So although it is 402 PMT, but inside this PMT, you have interest inside. And what's the interest? The interest is 100. So if you minus the interest, you will get the principal that you pay in year one, which is 402.11 minus 100, equals to 302.11. The last step, you need to find the ending balance. The ending balance after year one. So the ending balance after year one will be equals to beginning balance minus principal. So what's your beginning balance? So beginning balance is already 1,000. You can see from the question, beginning balance is 1,000 minus the principal payment. Principal payment is 302.11. So can you see 1,000 minus the principal payment? So this is your ending balance. So step 1 to step 4 is only for the first year. So by calculating step 1 to step 4, you have already calculated the first row of this table. So this is the amortization table. You can see before we can find or we can use draw the amortization table, we need to follow step 1, 2, 3, and 4. We need to follow all these steps. Step 1, step 2, step 3, step 4. Only that we can have our first year. You can see beginning balance 1,000, PMT 402, we already calculated. Interest 100 for the first year, we already calculated. Principal repaid in year one 302, we already calculated. Ending balance 698, we already calculated. So you just key in the value for the first year. Then for the second year, you repeat the same process. Step 1 to 4, you repeat again. So you can see in the ending balance in year one will become the beginning balance in year two. The PMT is equal, it is fixed, it is still 402. The interest in year two, how do they get 70? You multiply the beginning balance by the interest rate. So 698 multiplied by 0.10, you get roughly 70. So how do you get your principal payment? You minus the PMT minus the interest. So 402 minus 70, you get 332. So how do you get the ending balance for the year two? You minus the beginning balance minus the principal repayment. So you get the ending balance for year two. So ending balance in year two will become beginning balance in year three. In year three, you still have to pay your 402 annuity, which is equal every year. Then the interest, how do you get the interest? You multiply beginning balance 366 multiplied by the interest rate 0.10, which is 10%. You get 36, roughly 36. Then how do you get the principal payment of 366? You minus annuity, principal payment, minus, the PMT, annuity, minus the interest. You get 366. And what is the ending balance? So ending balance is beginning balance minus principal repayment. So you can see that this amortization table eventually will give you 0. Why is it 0? Because you are repaying back your loan, or you are repaying back the amount you owe. So by the time you finish paying the loan, you will have ending balance of 0, meaning that you have finished paying all your debts. So this method is applicable when you borrow to buy a car and you are paying back the car loan every year, depending on how many years you are given. So this table, sometimes it can be up to 6 years, it can be up to 10 years. The process is the same. Sometimes they can tell you that this table is monthly. It's still the same procedure. The only difference is instead of year 1, you have month 1, month 2, month 3, month 4, month 5. But the procedure is the same. And this question will come out in your exam. Usually question 1 is related to this. So when you look at this table, you will notice something, that the interest paid is declining. Can you see? In year 1, the interest is 100. In year 2, the interest declined. In year 3, the interest declined. Why is it declining? Because the ending balance is reducing. See, as the ending balance is reducing, you can see that your interest is declining. Why? Because you are paying back the loan. So this table or this figure tries to explain what is happening in this table. So you can see that you have your PMT, which we have calculated in the step 1. Then we have our principal repayment, which is 302. And this principal repayment, the difference between the PMT minus the interest will give us the principal repayment. And we know that the principal repayment, if you can see from here, the principal repayment, you can see slightly is increasing, 302, 332, 366. But because the ending balance is declining, the interest is declining. So that is what this table is trying to tell us. So any question? Oh, any question?
No, doctor.
All right. So, but remember, sometimes the period may not be year. Sometimes it can be monthly, month 1, month 2, month 3, month 4, month 5. So in this case, don't need to panic. It's still the same process. The only difference is if it is monthly, then you have to calculate the effective annual rate. Remember, I showed you if the frequency of compounding is monthly, then you need to find the effective annual rate. So you replace this one with the effective annual rate. Then you can find the PMT. You can find the PMT. And once you get the PMT, then the process will be the same. So instead of writing year 1, year 2, you just change year to month. Month 1, month 2, month 3, month 4. It's the same process. Once you get the first step, the second step, third step is the same. Just repeat the same process. All right, so if there's no question, okay, so I think most of you did well in the test. So it shows that you are reading using the Tuesday to read. So the same strategy will continue. Tomorrow you do revision so that you can prepare towards the second test. So second test is usually challenging, more challenging than the first test. So make sure you use your Tuesday to revise your note. All right, so if there's no question, so see you next week.
Thank you, doctor.
All right.
Thank you, doctor.
All right.
Thank you, doctor.
All right.
Thank you, doctor.
Yeah, welcome.